We've got stone tools in Britain far earlier than we thought, and in an environment where we didn't think early humans were able to live 900,000 years ago. So it really increases our understanding of their capabilities at this time.
At the moment we're sitting of course by the coast, but 800,000 years ago the landscape would have looked very different. We'd have been sitting in an early course of the River Thames in its estuary, and the actual coast would have been about 15 miles out that way. The river valley itself would have been nice and grassy and open, but would have been surrounded by pine forest. And if we carried on walking down the river to the coast and carried on walking around the edge of the coast, at this time we were joined to Europe and we'd end up somewhere like Amsterdam. Until recently we thought humans didn't reach northern Europe till about 700,000 years ago.
So we have people at 700,000 years at Pakefield in Suffolk, and those people were living under Mediterranean conditions, hot dry summers, warm wet winters. We thought they were able to come up briefly in those very warm times, and that's the only time they could get up here across a land bridge that existed. But now with the new Haysborough data we have evidence that even earlier than that they were actually here under cooler conditions, conditions which were in some ways comparable with conditions we might find in, say, southern Scandinavia at the present day. Quite demanding conditions for early humans, and yet they were here in Britain surviving under those conditions.
The remarkable thing about Haysborough, and the reason that we can find this rich evidence, is that as the cliffs erode back they reveal these river sediments, and these sediments contain remarkable things like wood, animal bones, tiny little things as small as beetle remains, and most importantly of all, we have the evidence of humans in the stone tools that they left behind. This is one example of the type of flint tools that we're discovering at the site, and in fact we've only found 60 of these over the last 5 years' work, so they're remarkably rare. But the important thing is that they indicate that humans were here. And this particular piece we nicknamed the butter knife because it's so finely made, and you've got this beautiful retouch down that edge. And in fact this one piece we sent to the Natural History Museum.
CT is basically a method for digitally sectioning an object. We take the stone tool and then using X-rays collect a series of cross-sectional slices through the specimen, and then stack those slices up to make a reconstruction of the specimen, but digitally and on a computer. As far as we know, this is the first time anybody's used computer tomography to analyse stone tools and produce 3D models, and hopefully we can be the first people to start sharing the data and really help try and convince people that what they're looking at is a human-made tool and not just a natural artefact.
What Richie's got with this technology is a way of capturing the shape of these pieces. This flake has been struck off, and we can see here the so-called bulb of percussion. So there was a blow that detached this flake that was made purposefully in that position, and then there's been further modification along the edges by further refined workmanship. So nature might make one or two blows like this in a river gravel, but the systematic flaking we see on a piece like that is only done by humans. We can see that it sits very nicely in the hand, and it's got a cutting edge on both sides. One edge is sharper, one's more a blunted scraping surface, but this would have been useful for skinning and butchering animals, getting the meat off the bones.
So we've seen the stone tools that Chris and Richie were looking at, and we understand how the tools were made and possibly even used. But here on the site we're looking at the context. These gravels were laid down by the ancestral Thames, and Nigel's just uncovered a fragment of wood, which is the trunk and the roots of a small tree. And it's important because we can identify the plants and the animals that were in the landscape associated with humans. So it provides a huge amount of information about the climate, environment and landscape at that time. So this is just a range of some of the vertebrate fossils from the site. This is a tooth of a primitive mammoth. These animals show that the environment was very rich. So you have a large herbivore fauna, but also the carnivores that were eating these animals, and presumably humans were also eating some of the large mammals. We've also got aquatic animals. This one here is stunning, beautifully preserved jaw of an extinct semi-aquatic rodent, and you can see the teeth are still in place in the jaw. So again, that's another animal that indicates quite open environments, slow-flowing rivers or ponds, large lakes. We've also got plant fossils, and because the sediments are waterlogged and deposited very quickly, the preservation is truly remarkable. This is a pine cone, and it's close to 1 million years old, but it's still recognisable as a pine cone. And from all of these finds, we can build up a very detailed picture of the environment. From the plant fossils, the pollen, we know that the vegetation was mostly coniferous. So if you're looking at a modern day analogue, you would go to the boreal zone in southern Scandinavia with a mixture of deciduous but dominant coniferous trees.
So they're living near boreal forests, and they're surviving winters that are colder than the present day. And the summers were warm and reasonable, but the winters were cold. And to get through those cold winters, they must have had significant behavioural adaptations to cope with those conditions. So it takes us up a notch in our understanding and appreciation of what these early people were capable of. And of course, as a paleontologist, I'm hoping that we're going to find some human fossils to go with these stone tools to really show what these early people looked like.